Welcome. Today we have a very specific, somewhat ambitious mission, I think. We're going to build a mental model that clarifies exactly how the developing brain constructs its very reality out of early relationships.
Right, yeah, it's a massive topic.
It really is. And we're using Chapter 3.6 of Kaplan and Sadok's comprehensive textbook of psychiatry as the absolute spine of our deep dive today. The goal here is to strengthen clinical reasoning by bridging two domains that, historically, well, they wouldn't be caught dead at the same dinner party.
No, absolutely not.
You've got psychoanalytic object relations theory on one side and contemporary hard-nosed neuroscience on the other.
It's a bridge that is just absolutely essential for modern clinical practice, though. I mean, it gives us our guiding philosophy for this deep dive, which is this: psychiatry is the study of how brain, mind, and experience interact, and crucially, how that complex interactive process can go wrong.
Exactly.
We are not just talking about psychology today. We're not just talking about biology. We are examining how interpersonal experience, literally physical, builds the architecture of the brain.
Right. And to wrap our heads around that, before we dive into the neuroscience, I want you, the listener, to try and visualize this. Imagine the developing infant brain not as a computer or a machine, but as a rapidly growing, entirely unpopulated city.
I like that. Unpopulated.
Yeah, because before anyone even arrives before birth, really the basic infrastructure is already laid down genetically. You know, the grand grid of the roads, the plumbing, the raw electrical wiring, it's all there, built in utero.
Right, the structural foundation is set.
Exactly. But the actual character of this city, the flow of its traffic, the decision of which specific neighborhoods become safe havens with thriving markets, and which neighborhoods become neglected, dark places of dread.
Yes, the lived experience of the city.
That character isn't genetic. That is built entirely by the very first massive influx of residents. And in the human mind, those first residents are our earliest caregiving relationships.
I think that is a deeply accurate way to frame it, because those first residents, they don't just visit the city on a tourist visa, they move in permanently.
Right, they set up shop.
They do. They write the local traffic laws. They determine the zoning regulations that will essentially govern all future movement through those streets for the rest of that individual's life.
They dictate the routes we take, the emotional highways we default to, forever. And understanding how that happens requires us to look at a monumental shift in how we understand human development.
It does, yes. We really have to start by moving beyond the pleasure principle.
Right, the massive shift away from classical Freudian psychoanalysis. Because for a very long time, Sigmund Freud's model was the absolute undisputed lens through which we viewed the developing mind.
It was. For decades, Freud's drive structure model really dominated everything. And to understand the shift, we have to understand what Freud actually posited.
Yeah, let's unpack that.
He argued that the human mind is fundamentally driven by a clash, an inherent conflict. On one side, you have innate biologically rooted pleasure-seeking drives, what he called libido, stemming from the id.
The raw demand for gratification.
Exactly. And on the other side, you have the restrictive, frustrating reality of the external world, and eventually the internalized social rules, the superego.
So it's a model of perpetual internal friction then. The infant wants immediate pleasure, and the world says, no, you have to wait.
Precisely. It is a closed system model. It was very heavily influenced by the thermodynamics of Freud's own era, actually the 19th century steam engine.
Oh, right. Pressure builds up, demands release.
Yes. Pressure builds and it demands release. If the release of pleasure is blocked, well, it causes neurotic symptoms. That was the foundational premise of psychiatric thought for a very long time.
But then we get to the mid-20th century, and a major modification arrives. We see the emergence of object relations theory.
Yes.
We are talking about brilliant clinicians and observers like Melanie Klein, Ronald Fairbairn, and later Otto Kernberg. And they were actually looking at infants, studying early childhood interactions. And they realized Freud's steam engine model just didn't quite fit.
No, it didn't fit the primary developmental engine they were witnessing. They realized it was incomplete. They argued that the innate driving instinct of the human mind is not actually to seek abstract pleasure.
Right.
The primary innate instinct is to bond.
I want to pause here because that sounds like a subtle shift, but I suspect it fundamentally changes everything. Bonding over pleasure. Why was that such a seismic earthquake in how psychiatry views the mind?
Well, because it roots our psychological development firmly in evolutionary biology, rather than just abstract drive theory.
Okay, how so?
Bonding is a survival instinct. It is deeply conserved across all mammalian species. Think about it. A human infant is born entirely, profoundly helpless. If its primary overriding drive was just abstract pleasure, it wouldn't survive a week.
You would just lie there waiting to feel good.
Exactly. We seek out caregivers, what psychoanalysts technically call objects, because proximity to those specific people equals survival.
So the infant isn't crying for milk just because milk feels good on a pleasure level. The infant is crying for the mother because the mummy is a lifeline. The pleasure of being fed is secondary to the safety of the bond.
Spot on. Pleasure is certainly a byproduct of being fed, being held, being kept warm. But the primary evolutionary driver, the thing the brain is desperately seeking, is the interpersonal bond itself. We are fundamentally relation-seeking creatures, not just pleasure-seeking creatures.
Okay, we need to decode some terminology for the listener here because this can get confusing if we aren't careful. In everyday language, when I say object, I mean a coffee cup or a microphone or a chair.
Yes, of course.
But in psychoanalytic object relations theory, an object isn't an inanimate thing at all.
No, it is a slightly counterintuitive term for modern ears. In this context, an object is a person, specifically the object of our relational drives. And when we talk about internal objects or object relations, we are talking about mental representations of significant others. Usually this begins with the primary caregiver. It is a representation that carries a very strong, highly specific emotional charge.
So it's the version of your mom or your dad that lives permanently inside your head. It's your internal template of them.
Yes, but it's vital to understand the precise structure of this template. An object relation isn't just a static photograph of a person in your memory. It is a dynamic triad.
A triad. Okay, what are the three parts?
It consists of three inextricably linked components: a self-representation, an object representation, and the affect.
The affect being the emotion.
Exactly, the intense emotion, whether that is profound pleasure or terrifying displeasure, that links the two together.
So it's not just a memory that says, here's a picture of my mother. It's a relational script. It says, there is my mother looking down at me. The object here is me feeling warm and full of the self, and here is the feeling of absolute, unshakable safety, the affect flowing between us.
Exactly. Or, conversely, if things go wrong, the triad might be, there is my mother looking angry and distant. Here is me feeling tiny, helpless, and terrified, and the affect linking us is sheer panic.
Wow, okay.
The critical takeaway is that the relationship itself is the basic building unit of the mind. The interpersonal experience between two humans is internalized to become an intrapsychic structure within one human.
The outside world gets folded inward to become the architecture of the mind. That's incredibly profound. But to understand how a fleeting interaction, a look, a touch, a moment of feeding, actually becomes a permanent physical structure in the tissue of the brain, we have to look at the underlying physics.
We do, yes.
And the sources for this deep dive bring in some incredibly dense concepts here. They describe the brain-mind as an open, self-organizing, dynamical system.
Yes. This is where the psychoanalytic observations finally meet modern neuroscience and physics. To understand how the mind builds itself, we have to acknowledge that the brain is subject to the laws of thermodynamics.
I have to push back on this a bit, because when you say thermodynamics, I think of car engines and boiling water. We are talking about human psychology, subjective experience, love, fear, and psychiatric distress.
I completely understand the hesitation.
Aren't we reducing the profound complexity of human emotion to a cold, deterministic physics equation? Where is the humanity in that?
It's a very fair challenge, and it's a tension that psychiatry wrestles with constantly. But bringing in physics doesn't negate the humanity. It actually explains how something as profound as human subjective experience can arise from biology.
Okay, so how does it explain it?
Well, when we say the brain is an open, self-organizing system, we mean it operates far from equilibrium.
What does that actually mean in practice? Far from equilibrium.
In physics, equilibrium is a state of rest. It is maximum entropy, maximum disorder, a flat line. For a living organism, equilibrium is death.
Ah, right.
To stay alive, to stay far from equilibrium, the brain must constantly import order from its environment to stave off that internal disorder. It has to pull in energy and information.
So it's actively resisting chaos.
Precisely. The brain doesn't just sit inside the skull passively recording the world like a video camera. It actively, constantly self-organizes to predict the world, adapt to it, and manage the chaotic influx of sensory data.
And it doesn't start this process from absolute zero, right? Going back to our city metaphor from the intro, the basic roads are pre-planned.
Correct. And this is where genetics comes in. The text points out that most large-scale brain networks, things like the sensory motor networks or the foundational architecture for the language network, are pre-assembled in utero.
So the wiring is there before the baby is even born.
Yes. The genetic code lays down embryonic neural networks, and these networks are synchronized by spontaneous intrinsic electrical activity before the baby ever opens its eyes or hears a single spoken word.
They're essentially doing dry runs in the dark.
Yes, exactly. In dynamical systems theory, we call these early preassembled networks seed attractors.
Seed attractors. So they are planted in the soil, ready and waiting to pull in information.
Exactly. They are structural predispositions. They are waiting for environmental input, the specific cadence of a mother's voice, the physical sensation of being rocked, the visual input of a face.
And when that input hits,
When that environmental input hits the seed attractor, it provides the information necessary for that network to fully organize, differentiate, and become functional. The mind itself, our distinct personality, our capacity for empathy, our subjective experience is what we call a multi-level emergence from these biological networks interacting with the specific environment of the caregiving relationship.
so to stick with the metaphor, the biology provides the soil and the genetic seeds. But the early caregiving relationships are the specific climate, the water, the sunlight, the storms that determine exactly how, or even if, those seeds are going to grow into a healthy ecosystem.
That's a brilliant way to put it, yes.
Which brings us to a really fascinating mystery. If early relationships form the literal physical blueprint of the mind, where and how are they actually stored? Because neither of us can consciously remember being 6 months old. Infantile amnesia is universal. Yes, it is.
So how can an experience that I have completely forgotten dictate my reality 30 years later?
It is one of the great paradoxes of human development. We are shaped by experiences we cannot recall, but the key is understanding the difference between explicit, conscious recall and implicit structural memory.
Right.
Forgotten, in the conscious sense, absolutely does not mean erased in the neural sense.
It's a bit like learning to ride a bicycle or learning to walk, isn't it? You don't have an explicit episodic memory of the specific Tuesday when you fell over as a toddler, or the exact moment your foot first found the perfect balance point.
No, you don't.
You can't retrieve that specific memory. But the balance, the intricate mechanics of walking are permanently implicitly encoded in your muscles, your basal ganglia and your cerebellum. The episodic memory of the event fades, but the implicit rule, the schema of how to walk, remains forever. That is a fantastic analogy. And contemporary neuroscience is finally proving that this exact same process happens with our earliest emotional relationships. The sources for this deep dive highlight some truly groundbreaking optogenetic studies done in rodents.
Oh, this is the work by Susumu Tonegawa and his colleagues, right?
Yes, exactly. Tonegawa's team.
Let's explain optogenetics for the listener who might not be familiar. This is where scientists literally use light to turn specific neurons on and off in living animals, right?
Yes, they genetically modify specific neurons so they become sensitive to light, allowing researchers to activate or silence exact neural pathways with a laser.
It sounds like science fiction.
It really does. But what Tonegawa's team demonstrated is profound. They showed that episodic memories from infancy-specific events that happen to a young pup are indeed forgotten as specific recallable events as the animal matures, but the memory trace is nearly preserved as what they call enneagram complexes.
Enneagram complexes. Let's really dig into this. What is the actual physical anatomy of an enneagram? When an infant experiences something profound, where does it go in the brain?
An episodic memory isn't stored in one single neat little filing cabinet. It is highly distributed across different brain regions.
Okay.
When an infant has an intense relational experience, say, a terrifying moment of being left alone, or a blissful moment of being held and fed, different parts of the brain take different notes, the hippocampus is primarily responsible for the what, where, and when. It encodes the semantic-like context, the raw facts of the episode.
The physical setting of the scene.
Yeah.
The crib, the blanket, the room.
Yes. Meanwhile, the amygdala, deep in the limbic system, encodes how it felt. It records the contextual affect.
The emotion.
Yes, the raw, unconditioned emotion, the pure visceral terror or the pure soothing pleasure. And then, crucially, you have the MPFC, the medial prefrontal cortex.
What is the MPFC doing while the hippocampus takes the facts and the amygdala takes the feelings?
The MPFC acts as the index. It is the librarian. It ties these highly distributed networks together into a coherent schema. It holds the map that says this context in the hippocampus is linked to this specific emotion in the amygdala.
But if that memory trace is laid down, why do we forget the specifics? Why the amnesia?
Because of a process called systems consolidation. Over a period of weeks and months, the original memory trace in the hippocampus actually fades.
It just disappears.
Essentially, yes. The physical connections, the dendritic spines on those specific neurons decrease. The hippocampus clears its cache, so to speak, to make room for new learning. But as the hippocampal trace fades, the MPFC matures into the active holder of this memory. It takes over. And in doing so, it semanticizes the memory.
Explain semanticize. It turns it into semantics, meaning it strips away the highly specific details, the exact time of day, the color of the blanket, the specific smell of the room, and extracts the core gist or the fundamental rule of the experience.
Precisely. The episodic memory of a specific event converts into an implicit semantic schema, a rule about how the world works. It becomes an internalized object relation.
Wow.
The brain stops remembering the specific time Mom didn't come when you cried, and instead extracts the implicit rule. The world is unresponsive and, depending on people, leads to panic.
That is so bleak, but it makes total sense.
It's survival. That schema becomes what we call a fixed-point attractor. It constantly operates in the background of your mind, interpreting your current survival status based on those early general templates.
You use the word attractor again, fixed point attractor. The sources use this term heavily. I really want us to unpack this because it feels like a crucial mechanism for understanding how the mind gets stuck in certain patterns. In dynamical systems theory, what exactly is an attractor state in a human brain?
To understand an attractor, you have to think about the brain's network activity as a ball rolling across a three-dimensional landscape of hills and valleys. We call this an energy landscape.
Okay, picture a rolling ball.
The brain is incredibly metabolically expensive. It wants to conserve energy and avoid chaotic, random noise. So the network's activity naturally wants to roll down into a stable valley where it can rest. That valley is the attractor.
So an attractor is a state of equilibrium or stability that the brain naturally gravitates towards to save energy.
Yes. At a neurological level, an attractor is a highly stable, synchronized pattern of neuronal firing. When a brain network falls into an attractor state, it produces a coherent thought, a coherent memory, or a coherent relational expectation, pulling order out of the chaotic firing of billions of individual neurons.
It's the groove in the record. Once the needle finds the groove, it just naturally wants to stay there and play that specific tune.
That's a perfect way to put it.
But how do billions of microscopic neurons actually coordinate this? How do they all decide to fall into the same valley at the same time? The text mentions concepts like theta-gamma nests and neuronal avalanches. It sounds chaotic, not orderly.
It sounds chaotic, but it is actually a masterpiece of biological engineering. Individual neurons fire incredibly fast, in milliseconds, but a thought, or an emotion, or an object relation takes seconds to unfold.
Right, there's a huge time difference there.
Exactly. How do you bridge that massive temporal gap between a millisecond spike and a 2-second feeling of sadness? You need a mechanism to link the fast and the slow. That is where theta-gamma nests come in.
Okay, break down the nest for me.
The brain generates different frequencies of electrical waves. Theta waves are slow, broad waves. Gamma waves are very fast, high-frequency waves.
Okay, got it.
In a theta-gamma nest, the slow theta wave acts as a carrier. As the theta wave peaks, it creates a brief window of high excitability, a nest, where a burst of fast gamma waves can ride along.
So the slow theta wave is like a massive cargo ship crossing the ocean. And the fast gamma waves are the thousands of individual shipping containers stacked on top, full of specific data.
Yes. That is a fantastic way to visualize it. The slow wave coordinates the timing across vast regions of the brain, ensuring that the highly detailed fast data in the gamma waves arrives exactly where it needs to go, in perfect synchrony.
Oh, I see.
And when this synchronization hits a critical threshold across the network, you get a neuronal avalanche.
A neuronal avalanche. I'm picturing a stadium wave at a football match. One section stands up, and suddenly the whole stadium is coordinated in a massive cascade.
Exactly like a stadium wave. It's a cascade of coordinated activity that sweeps across the cortex. That avalanche is the network falling into the attractor valley. It is the physical manifestation of a thought or an internalized object relation locking into place.
And the sources point out that this landscape, these valleys, change depending on what the brain is actually doing.
Mm-hmm.
There's a big difference between how the brain operates when we are actively doing something versus when we are just staring out the window. Let's talk about the default mode network versus task-positive networks.
This is a crucial distinction for clinical reasoning. When we are actively engaged in a specific task, solving a maths puzzle, driving a car in heavy traffic, actively talking to someone, our task-positive networks, like the frontoparietal network, take over.
Right.
In these states, the energy landscape of the brain is multi-stable.
Multi-stable, meaning many different valleys.
Yes. The landscape is rough, filled with many shallow valleys. The brain needs to be agile.
Yeah.
It is rapidly hopping from one shallow valley to another, constantly shifting attractor states to process rapidly changing external demands. You check the mirror, you hit the brake, you adjust the steering wheel. Quick, agile shifts.
Jumping from shallow puddle to shallow puddle.
Exactly. But when we finish the task, when we are at rest, when we close our eyes and our minds just wander, we default to the default mode network, the DMN.
The famous DMN.
Yes. And at rest, the network dynamics change completely. The landscape fundamentally alters. It undergoes what we call deep learning. The many shallow valleys merge together into one deep single valley. The network becomes monostable.
A single massive canyon. Why does the brain do that at rest?
Because a monostable state allows the brain to process deep, gist-like learning. It isn't distracted by the immediate demands of the outside world. It uses this deep valley to integrate the day's experiences, consolidate memories, and weave new information into our core identity and long-term relational schemas.
So what does all of this deeply complex physics and neurobiology mean for a developing infant? Because if we connect this to the bigger picture, an infant's brain isn't fully formed, the city is still being built, the valleys are literally just being carved out by their early experiences.
And that leads us directly to one of the most profound clinical manifestations we see in psychiatry. We have to look at how an infant's developing biology handles massive contradictions in their environment.
Right. This is where it gets incredibly clinically relevant, because an infant is totally, utterly dependent. The caregiver who provides comforting milk, who's the source of all warmth, soothing, and survival, is the exact same caregiver who inevitably causes intense frustration.
Yes, unavoidably.
The caregiver puts the baby down, leaves the room, or just doesn't feed them fast enough. To an adult, that's just a busy parent. To an infant who has no concept of time, that absence is a matter of life and death. How does an immature developing brain handle the intense contradiction that the source of ultimate good is also the source of ultimate terror?
It handles it by dividing the mind. It literally splits the experience in two. To survive the contradiction, the brain creates two separate realities. We are talking about the neuroscience of partial object relations, or what psychoanalysts famously call splitting.
Splitting. Let's look at the actual biology of a divided mind. You mentioned earlier that the amygdala is the structure that encodes the raw emotion, the effect of a memory.
Yes, and recent research, specifically highlighted by Joshua Kim and his colleagues, reveals something absolutely fascinating about how the amygdala develops.
What did they find?
The infant's contradictory affects the highly rewarding feelings of being fed and held versus the highly frustrating, terrifying feelings of being abandoned or hungry are encoded by entirely separate, genetically programmed groups of neurons within the amygdala.
Wait, they are physically segregated?
Yes. There is a specific cluster of neurons strictly dedicated to encoding reward and a completely separate, distinct cluster strictly dedicated to encoding frustration and fear.
So the infant's brain physically cannot mix the two feelings at the amygdala level. The hardware won't allow it.
Precisely. The signals are anatomically segregated. Now, in an adult, the prefrontal cortex, the MPFC, our librarian would receive both signals and synthesize them, saying, I love my partner, but I'm currently annoyed with them.
Right, holding two truths at once.
Yes, but because the infant's MPFC is highly immature and underconnected at this stage, it simply lacks the processing power to reconcile these two opposing powerful signals from the amygdala.
So what happens to the network? It just breaks.
The mind is forced into what dynamical systems theory calls a be-stable state. The network is locked into mutually exclusive fixed-point attractors.
Let me visualize this. Be stable. Two valleys. But unlike the shallow valleys we talked about earlier, these are two deep valleys separated by a massive, insurmountable mountain ridge.
Yes.
The ball can be in one valley or it can be in the other, but it can never, ever be in both.
That is the exact mechanism of splitting. Phenomenologically, in terms of the infant's subjective experience, this means they experience the caregiver not as one complex, nuanced person with good and bad traits, but as two entirely separate, disconnected entities.
Two different people, essentially.
Essentially, yes. When the caregiver is gratifying, feeding, and soothing, they are experienced as the all-good, idealized object. There is no memory of them ever being bad. But the moment the caregiver is frustrating or absent, they instantly become the all-bad, persecutory object. And there is no memory of them ever being good.
It's almost eerie how perfectly the modern neurobiology maps onto the clinical observations made nearly a century ago. Because this biological-based stability is exactly what Melanie Klein describes psychologically as the paranoid schizoid position.
It is a stunning validation of her clinical intuition. Klein theorized that the infant is overwhelmed by survival terror, what she called the death instinct.
Heavy term.
It is. To cope, the infant projects this terror onto the bad breast, the frustrating caregiver. But crucially, the infant does this to protect the good breast, the loving caregiver, from its own aggressive, destructive impulses.
The infant splits the world into absolute pure good and absolute pure evil because it simply lacks the cognitive capacity to tolerate the ambiguity.
Yes. By keeping them completely separate in a bestialable state, the infant ensures that the vital, life-saving good object isn't contaminated, poisoned, or destroyed by the terrifying bad object.
It's a biological defense mechanism. The brain is calculating, I have to keep the memory of the life-saving food totally, hermetically sealed from the memory of the terrifying abandonment. Otherwise, I will feel like my only lifeline is toxic and I will despair.
It is entirely adaptive at that stage of infancy. It keeps the baby functioning. But, of course, we can't stay in that paranoid split state forever if we are going to grow up and function in a complex, nuanced social world. We have to be able to handle people being imperfect.
Right. Which brings us to a massive developmental leap, the transition from partial split objects to integrated or whole object relations.
Exactly.
Okay, let's drive the timeline forward. We move from early infancy into toddlerhood. We are looking at a child around 2 to 3 years of age. What is physically changing the neurobiology that allows this toddler to stop splitting the world into angels and demons?
It is driven by the anatomical maturation of the MPFC. As the medial prefrontal cortex develops more synaptic connections and gains more processing power, it finally becomes capable of handling relational complexity.
It builds the bridge.
Yes. It starts to bridge that insurmountable mountain ridge between the two valleys. The child begins to slowly realize that the terrifying, frustrating parent who firmly said no to a toy is the exact same singular person as the loving parent who read them a bedtime story an hour ago.
Honestly, that sounds computationally exhausting for a developing brain. To hold intense love and intense frustration simultaneously, how does the brain do it without crashing or reverting back to splitting?
It achieves this by entering a dynamic network state called metastability. This is a profoundly beautiful concept adapted from physics. Remember the bistable state, the two rigidly separate valleys?
Yep.
In metastability, the brain network is operating near criticality. It is hovering right on the very boundary between rigid order and chaotic disorder.
Wait, metastability, I understand metastable, two separate valleys. But what does it actually mean to be metastable? Is it just a wider valley? I'm going to need an analogy for hovering on the boundary of chaos, because that sounds precarious.
Think of water right at the exact freezing point. It is neither fully solid ice nor fully liquid water. It is shifting between states, highly responsive, highly adaptable. When the MPFC reaches metastability, it uses what are called ghost attractors.
Ghost attractors. Again, I love the terminology. It sounds like a sci-fi novel. But what is a ghost attractor conceptually?
As the MPFC matures, the rigid, fixed-point attractors of the all-good and all-bad states weaken. The deep valleys become shallower. They become ghost attractors, meaning they still exert a gravitational pull, they still exist as underlying tendencies in the network, but the brain is no longer hopelessly locked into them.
So it can escape the valley.
Yes. The MPFC has enough power to hover above them, holding on to both the positive memory of the good mother and the negative memory of the frustrating mother, without letting those memories annihilate each other.
So the contradictions remain quasi-independent. The brain acknowledges, yes, Mummy was incredibly angry yesterday, and yes, Mummy is incredibly loving today. The memories don't blend into a gray, emotionless mush. They stay distinct, but they are cognitively reconciled and housed under a single overarching concept of whole money.
Exactly. The MPFC transitions the mind from a rigid bistable state of splitting to a fluid metastable state of synthesis. And the psychological result of this biological maturation, which Melanie Klein famously called the depressive position, is incredibly profound for the human experience.
Right, because the psychological fallout of this realization is huge. Once the toddler finally puts the pieces together and realizes that the bad parent they were raging against, the one they wanted to bite and destroy in their frustration, is the exact same person as the good parent they desperately love and rely on for survival. That has to be terrifying.
It is. It induces a profound, deeply uncomfortable anxiety and guilt in the toddler. The child realizes for the first time that their own aggressive, destructive impulses were directed at the very person they love most in the world.
They fear they've ruined it.
Yes, they fear they may have damaged the loved object. But this guilt is not pathological. It is essential. It is the birth of our humanity.
Because the guilt drives action.
Yes. It creates the drive for reparation. The child actively wants to make amends, to fix what they believe they have broken, to protect the caregiver. This drive for reparation is the biological and psychological genesis of genuine empathy, gratitude, and mature, complex love. It is the foundation of moral development.
It's the very moment we realize that other people are full, complex, vulnerable human beings, and that our actions actually impact and hurt the people we love. That is a staggering developmental milestone.
It truly is.
But as we transition to clinical reasoning and how this applies to modern psychiatry, we have to acknowledge the dark side. This incredibly complex process of moving from biastability to metastability doesn't always go smoothly. How do these early infant neurodevelopmental stages manifest when things go wrong? And we end up seeing an adult patient sitting across from us in a psychiatric clinic.
Well, to deeply understand psychopathology, we first have to look at the raw biological materials the infant brings to the table, their innate temperament, or what we call affect reactivity. And we have to see how that temperament interacts with the brain's resting state networks.
So we're not all born as identical blank slates. Some infants are just naturally wired to be more reactive to the world.
Exactly. The research, prominently highlighted by Caroline Kelsey and colleagues, shows that neonates are born with distinct innate dispositions towards either negative or positive affectivity.
Okay.
And this innate disposition heavily influences how their brain networks organize themselves over time. Neonates with an innate negative affectivity, those who are easily distressed, startle easily, and are very hard to soothe, show hyperconnectivity in the default mode network, the DMN.
Wait, let's connect this back. The DMN is the monostable network we use when we are at rest, when we are processing internal thoughts and consolidating memories, right?
Yes. And if a highly reactive infant has hyperconnectivity in the DMN, it leads to an intense preoccupation with stimulus-independent, self-referential thought. Basically, the infant's brain becomes excessively tuned inward. It gets stuck focusing on its own internal distress, its own bodily discomfort, its own anxiety. And crucially, they simultaneously show hypoconnectivity in the frontoparietal network, the FPN.
The task-positive network.
Yeah.
The one used for agility and engaging with the outside world.
Right. So hypoconnectivity in the FPN means they have poor executive control and a very slow, sluggish reorientation of attention to the outside world.
So a baby with high negative affectivity is neurologically trapped in a feedback loop. They feel bad. Their brain is wired to ruminate on feeling bad, and they lack the network agility to pull their attention out of that internal loop to look at a comforting face or a distracting toy.
Exactly. They are trapped in their own distress. Whereas neonates with innate positive affectivity show the opposite pattern. They have much better connectivity in the FPN. This allows them to effectively balance internal processing with external attention.
They can snap out of it easier.
Yes, they can shift their focus away from distress and toward a comforting caregiver more easily. And this is a vital vulnerability factor clinically because the human brain inherently prioritizes negative and aversive stimuli for survival.
Right, the evolutionary negativity bias. Missing out on a reward is a bummer, but missing a predator in the bushes is fatal. The brain is always wired to care more about the bad stuff.
Yes. And negative affect has what dynamical systems theory calls hysteresis in the neural network.
Hysteresis. Let's unpack that.
Hysteresis means the system has inertia. It remembers its history. Once a network falls into a negative, distressed attractor state, it sticks around. It resists change.
Stubborn.
Very stubborn. It takes a massive amount of active, high-level energy to push the network out of that negative valley and transition the infant back to a calm, positive state. If an infant is highly reactive, constantly falling into negative hysteresis, and the caregiving environment isn't sufficiently attuned to provide that massive, consistent energy input to soothe them, well, the brain starts wiring itself defensively.
The city builds walls instead of bridges, which is the perfect entry point to understanding personality disorders, because this is where the theoretical neurobiology meets the intense reality of the clinic.
It explains the very core of personality pathology. If an infant suffers severe early adversity, chronic stress, trauma, or simply lacks what Donald Winnicott famously called good enough parenting, meaning a caregiver who is consistently attuned enough to help regulate that intense distress, the infant's brain never successfully makes that vital transition.
They never move from bastable partial objects to methystable integrated objects.
Precisely. The MPFC never gains the power to juggle the ghost attractors. The energy landscape of their brain stays rough, divided, and stuck in deep, rigid valleys. They fail to reach what we call self and object constancy.
So when these individuals grow up and eventually sit in your clinic for an assessment, they are operating biologically as adults, but relationally they're relying on preconceptual infantile schemas of absolute endangerment. Their MPFC literally cannot maintain the metastable synthesis of a whole object.
Exactly. This explains borderline personality traits with such breathtaking clarity. It explains why a patient with borderline pathology might think you are the greatest, most empathetic doctor in the world. On Tuesday, you are the all-good object.
Right.
And then, by Thursday, because you were 5 minutes late to their session, you are suddenly the devil, ye are abusive, and they want to destroy your career. It's not conscious manipulation, it's literal structural neurobiology. They are structurally trapped in splitting.
It is a rapid collapse into a bistable network state. The stress of the perceived rejection, you being 5 minutes late, overwhelms their fragile MPFC. The ghost attractors collapse back into a rigid, deep, fixed-point attractor of the all-bad persecutory object.
Yes, they cannot access the memory of you being good on Tuesday. And to protect themselves from this terrifying, chaotic instability, they might develop secondary psychological defenses.
Like what?
For instance, a compensatory grandiose self, which is the core of what we see in narcissistic personality structures.
Oh, okay.
If the internal world is a constantly dangerous place filled with unreliable, deeply split objects that might abandon you at any second, the only safe space, the only refuge, is a fantasized omnipotence. The internal logic is, I don't need anyone, I am entirely self-sufficient because I am superior to everyone. It is a defense against the terror of relying on split objects.
It's a tragic but brilliantly logical adaptation by a developing brain that is desperately trying to survive what it perceives as a hostile emotional environment. But that raises an enormous, arguably the most important question for psychiatry in practice.
Oh, heck.
If a patient's brain was physically wired this way in infancy, if their MPFC is structurally stuck in bistability and their amygdala is constantly dominating with threat responses, how on earth can a psychiatrist fix it 30 years later? Are we just managing symptoms with medication, or can we actually rewire this architecture?
We can rewire it. And the mechanism for this rewiring is arguably one of the most hopeful, profound concepts in modern neuroscience, metaplasticity.
Metaplasticity. The plasticity of synaptic plasticity. I know Hebbian plasticity neurons that fire together wire together. But how does metaplasticity differ? Let's unpack the mechanism.
Basic plasticity is learning a new fact. Metaplasticity means that the actual threshold for plasticity, how easy or hard it is for the brain to learn and change, can itself be altered by experience.
Okay, give me an example.
Think of it biochemically. Early chronic stress flooded the infant brain with cortisol, which physically altered the NMDA receptors at the synapses. It raised the threshold for learning safety, making the brain rigid and deeply entrenched in negative attractors.
So it's harder to learn to trust.
Exactly. Metaplasticity means that new, incredibly consistent, profound relational experiences can alter that biochemical baseline again, lowering the threshold for plasticity.
And what is a long-term psychodynamic psychotherapy relationship, if not a profoundly consistent, highly controlled new relational experience?
Precisely. This is why healing in psychodynamic therapy isn't just about intellectual insight. It's not just the doctor telling the patient, you have a borderline personality structure. Here is a worksheet.
Right.
Intellectual insight alone does not alter the dendritic spines in the MPFC. Healing requires a literal, physical reorganization of the brain's relationally constructed systems. The therapeutic alliance, the safe, consistent, profoundly non-retaliatory presence of the therapist over months and years acts as a massive new object relation.
I want to make sure I understand the mechanics of the clinic room. So week after week, the patient projects their bad object onto the therapist. They get angry, they test boundaries, they accuse the therapist of not caring.
Yes, that happens constantly.
And the therapist doesn't retaliate, the therapist doesn't abandon them, the therapist simply holds that emotion, survives the attack, and helps process it. How does that translate into neurobiology?
Every time the therapist survives the attack without retaliating, it provides a massive, unexpected, energetic input into the patient's rigid neural network. It contradicts the old schema.
It shakes up the system.
Yes. Over time, this consistent safety pushes the network out of its rigid, beastable valleys. The therapeutic relationship itself acts as a powerful new attractor. It lowers the threshold for plasticity, remodels the implicit schemas, and physically allows the MPFC to finally build the synaptic connections necessary to reach that state of metastability.
It allows the patient, finally, to tolerate ambiguity.
Exactly, to integrate the good and the bad and to experience whole object relations.
That is genuinely awe-inspiring. We are literally talking about using human conversation, empathy, and boundaries to coax a biological brain into growing new physical connections.
We are, yes.
Okay, we have covered an immense amount of ground today. We've journeyed from 19th century thermodynamics and optogenetic rodent studies all the way to Melanie Klein's observations of infants and the neurobiology of borderline personality disorder.
It's been quite a journey.
It has. And to solidify these mental models, before we finish, we're going to do a clinical review. We're going to present a few clinical concepts and scenarios. If you are listening, I want you to actively engage with this. I'm going to pose the question to our expert, but I want you to try and formulate the answer in your head. Try to beat them to the punch before they break down the mechanism. Let's see how well we've mapped this new city. Ready?
Absolutely. Let's run through them.
Okay. Scenario 1. Let's test the foundational concept. We spent a lot of time on the shift away from classical Freudian psychoanalysis. According to the object relation theory that replaced it, what is the primary innate driving mechanism of human mind development? Take a second here.
The answer is the innate instinct to bond, or object seeking. Unlike Freud's older drive structure model, which posited pleasure-seeking or libido as the primary engine of the mind, object relations theory roots our mind development firmly in the evolutionary survival-based necessity of forming attachments to our primary caregivers. We seek the bond first. Pleasure is a byproduct.
Perfect. Scenario 2. Let's move to the physical mechanisms of memory. When an infant has an intense early experience, it is stored as an engram complex. Which specific brain region is primarily responsible for encoding the contextual affect, meaning the pure, raw, unconditioned emotion of terror or joy of that early episodic memory? What do you think?
The answer is the amygdala. Remember the division of labor, the hippocampus encodes the semantic context, the facts of what, where, and when. The MPFC acts as the index that systems consolidates it into a schema over time. But it is the amygdala that securely and permanently holds the raw emotional valence, the actual feeling, of that early relational experience.
Spot on. Scenario 3. Let's bridge the psychoanalytic terms with the physics we discussed. The psychoanalytic concept of splitting or partial object relations where a patient views someone as entirely flawless or entirely evil is best explained by which specific neurodynamic state of the MPFC?
The answer is bistability. In a bistable state, the immature or heavily dysregulated MPFC cannot synthesize contradictory affective inputs coming from the amygdala. The network is essentially locked into mutually exclusive, fixed-point attractors. It falls into the valley of purely good or the valley of purely bad, entirely unable to blend the two realities.
That mental image of the two separate deep valleys divided by a mountain is the perfect anchor for that concept. Okay, scenario 4. Conversely, what is the dynamic network state that finally allows the maturing MPFC to reconcile those contradictory experiences with a caregiver, allowing the child to develop integrated, whole object relations?
The answer is metastability. This is the profound state where the brain operates near criticality, right on the edge of chaos and order. It weakens those rigid fixed-point attractors into ghost attractors. This allows the brain to hold on to and deeply process complex, contradictory relational realities without devolving into chaotic noise or snapping back into a rigid split order.
Brilliant. Scenario 5. A bit of clinical reasoning regarding innate infant temperament. In neonates, an innate disposition to high negative affect reactivity predicts hyperconnectivity, in which specific resting state brain network, often resulting in a lifelong preoccupation with stimulus-independent, self-referential thought.
The answer is the default mode network, or DMN. Hyperconnectivity in the DMN essentially traps the highly reactive infant in an internal loop of distress and negative mind wandering. Crucially, this pulls vital metabolic energy away from the frontoparietal network, which the infant desperately needs to engage with and be soothed by the external world and the caregiver.
Excellent. Final scenario, scenario 6. Returning to our psychoanalytic milestones. What is the name of the developmental milestone where a toddler finally realizes that their intense aggressive impulses were actually directed at the very same caregiver they deeply love, leading to feelings of profound guilt and the ultimate capacity for mature empathy?
That milestone is known as the depressive position. It succeeds the earlier paranoid schizoid position. It marks the profound, though highly anxiety-provoking, realization of whole object relations. It is the moment where love and hate are finally recognized as being directed at the exact same complex human being, sparking the drive for reparation.
Brilliant. Those scenarios really anchor the immense journey we've been on today. We started with the idea of medical precision, how we often wish the mind was like a broken bone on an X-ray, neat and binary. But we've seen that the diagnostic landscape of psychiatry is a deeply complex, incredibly dynamic landscape formed by our earliest connections.
It is, absolutely.
We are quite literally built out of the love, the fear, and the attunement we experience in our very first years. But I want to leave you, the listener, with a final, somewhat provocative thought to mull over as you go about your clinical day or your personal life.
I think this is an important one.
We've firmly established today that our basic neural architecture for processing reality, the ability of our MPFC to reach metastability, is forged by the deep, consistent, face-to-face attunement of early caregiving. The brain requires that highly specific, consistent human data to build its ghost attractors and learn to tolerate the ambiguity of love.
It does.
So, how might the modern era's unprecedented levels of relational fragmentation be altering this deeply conserved biological process? Think about the ubiquity of parental digital distraction. The modern still-face experiment, where a caregiver is looking blankly at a glowing smartphone instead of mirroring their distressed child.
Oh, wow. Yes.
Think about isolated nuclear parenting, completely separated from the evolutionary norm of the extended multi-generational village that used to help regulate infant distress. If our interpersonal environment literally dictates the thermodynamic organization of the brain, are we unknowingly shifting the baseline attractors of the human mind for the entire next generation?
That is a chilling thought.
Are we creating a societal environment that inherently favors rigidity, bistability, and splitting over the difficult, energy-intensive process of meta-and-expo integration? It's not just a philosophical question. It is a biological one. Yeah. And it's something we as a society, and most certainly as clinicians, need to think about very, very deeply.
Here are the details of this episode.
Neuroscience of psychoanalytic object relations. Byline. We're shaped not only by the brain we have, but by the relationships that built it.